All right. Welcome to Frank Teaches DevOps. Okay. In this series, I we shall be discussing how to set up an elastic Kubernetes service. So in this series, I shall describe how to set up an elastic Kubernetes cluster on AWS on AWS. Right? So this is what this series is all about. Setting up an EKS. Okay. Setting up an EKS on AWS. All right. Okay. So what is EKS? What exactly is EKS? So EKS is AWS managed Kubernetes service. All right. So EKS is what AWS named their own version, all right, of Kubernetes service. However, we have Kubernetes on premise. Okay, there is Kubernetes. Sorry, going forward, I will be using K8 and S to represent Kubernetes. So there is Kubernetes on premise on premise. So with Kubernetes on premise, I can use different tools like we can use kubeadm, kube ADM. We can use minikube, minikube. We can use what else again? What else? What else? What else? There are a lot of tools you can use to deploy Kubernetes on premise. Okay, on premise. However, for the cloud perspective, okay, for the cloud perspective, we have managed services. On the cloud perspective, we have Kubernetes managed services. All right. And from AWS, we have it as EKS. From Azure, we have it as AKS. And from GCP, we have it as a GKS. All right, GKS. So our focus in today's series is on EKS. Okay. All right. So let's now talk about the steps we shall go through in making all of these to work. All right. How to set up EKS on AWS. All right. Okay. So I'm going to create an IAM user, create an IAM user. So IAM is identity access management. All right. So this is the user I will be using to is a programmatic user I will use to connect to my AWS instance via AWS CLI. All right. So create an IAM user. I have one already, but I wouldn't want to use that user for now. Okay. Then two, create VPC. Okay, which is the network that the AWS cluster we use. Then create cluster and worker nodes roles. All right. Okay. Then four will be then I'll install some prerequisites, some tools, some features needed. Install AWS CLI, install AWS IAM Authenticator. This is used by the IAM user to authenticate with the Kubernetes cluster. Then finally, I'll now install kubectl, and yes, that's all. That's all. That is all. All right. That's all. As for the VPC part, I'm not going to be creating a VPC from scratch. I have an already created VPC which I'm going to leverage on. Okay. Then what else do we have to do? All right. So let's hop onto my AWS instance and get started. Okay. So the first task is create an IAM user. All right. So on my search bar, I'll search for IAM service. Takes time. I don't know why it's taking this time. Okay. Search for IAM. It's coming up. Why it comes up? Okay. So I'll go to users. I'll go to users. Mm, 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 I have a lot of users here. Okay. Let me use Omero. Let me use Omero. Let me use it. Admin access. And okay, security credentials. All right, I no longer have access to this, so I have to remove this for Dinero. Sorry, Omero. Deactivate, please. Cancel. All right, let's create a fresh. Let's create something fresh. So I'm going to download this file. I'll download this file, Omero access keys for the Omero users. All right, close. That's fine. Then I will go back to my EC2 instance. I need an EC2. I need a control machine where I will use to do all of these. I need a control machine. Let me add it. Um, 5. Use a. I have a control or remote machine handy. Okay, so have that handy. So I have one of my guys here. Do I still have access to this guy? Oh, let me just quickly create one. I'll be right back. Okay, I have my control machine. Then I'm going to connect to my control instance. All right. Okay, so on this machine, let's go back to yeah. So all right. So I have created the IAM user. Okay. So I need to authenticate with the IAM user, right? So let's authenticate that. And before I can do that, I may have to install AWS CLI. So let's see how to install AWS CLI. So I'm going to say install, go to Google, AWS CLI. Let's look for this. Let's look for AWS documentation. My version of Linux operating system is Linux. Okay. This 64 bits, obviously. So, all right. So for 64 bits, uh, x86 architecture, I'll copy this URL. I'll come up here, paste it, downloaded. Let's check. It's optional. They say I may need to unzip it. That was a zip, obviously. Oh, I have it. So let's unzip it. Okay, unzip is not found. So apt Install unzip. I need to do as a sudo. Okay, go. It takes some time. Okay. Now let's recall to unzip it. Unzip. All right. Let's sudo apt install AWS CLI. Let me see if this will work. Okay. It's like it's going through. I had to discontinue using the EC2 instance because it was hanging. So I had to use my Windows subsystem for Linux. Okay. So okay, that is done. So let's check if AWS is there. Perfect. AWS CLI has now been installed. So we shall now use our AWS CLI to connect to our AWS tenant. So what I will do, I'll say AWS configure. So it's requesting for the access key ID. So I downloaded something, Omero user. So the access key, we don't need to have this because after now I'm going to delete all of this. So access key is that, then secret key is that as well. Copy. Secret key is that as well. Then the region I'm going to use my region will be London what? EU West 2. So EU West 2 region. I want to operate from EU. EU West 2. Okay, that's it. So that's it. So let's confirm if actually our credentials is there. AWS I'll do a command AWS STS, okay, get get caller identity. Let's see who is logged on. Okay, so this is caller identity. User ID is this, account is this, and the ARN is Omero. So let's do another one. Let's say AWS. Okay, AWS. I am list users. I am list users. I can see that, oh, I have so many users here. So many users. So I am these users. I have this. I have this. Let me look for Omero user. Okay. Okay. I should have Omero. So this is Omero. Okay. All right. So this is me. Okay. I can grab that Omero. All right. So that's me. So it's coming as it is. Okay. So AWS CLI has been configured. So let's quickly set up. No, no, I'm not going through. Okay, let's quickly set up AWS Authenticator and kubectl. So we don't need to come back anymore. All right. So the next thing I'll do, I'll hop on to my Google, the same thing I did, and I will type AWS and say install IAM Authenticator. Okay. AWS IAM Authenticator, as we said earlier, IAM Authenticator is used for authenticating, um, is used by the IAM user to authenticate with the cluster. Okay, so my operating system is Linux, so I'm going to take this first option, copy this, come to my machine. So far, we don't have AWS IAM authenticator. It's not there. Okay, it's not there. So we want to install this. Want to get it installed. It's coming up. It takes some time. Okay. We've downloaded the AWS Authenticator. So let's make it executable. So this part is optional. Optional. Okay. This is the third part. Sorry. Copy. Copy. Okay. Great. Then what's the last part? The fourth part is this. Creates an environment variable. So that's it. Then the fifth part is that. So we can add it to our bash.bash RC. Then finally, you can just run this command to confirm if really the authenticator app is up. Great. So we now have our AWS IAM authenticator app is fully up and running. So let's go back. So we're done installing AWS CLI. This is number 4. We are done installing the IAM authenticator and we need to install kubectl. So the same process we use. So go back to our Google. So say install kubectl. Enter. Install kubectl. Um, all right. Let's put it like this. Install AWS kubectl. Let's see. Installing AWS CTL. Let's look for the best way. My platform is Linux. All right. So I don't know yet. Okay. Okay. Make sure that your cluster matches the version of the kubectl you're installing. So I'll be running Kubernetes cluster 1.21, 1.21. So this is fine. And yeah, what am I getting to? Okay. Why am I getting two of this? Let's see. What's the difference? US was 2. Okay, okay, okay. All right, take that. Come over here. Do that. Okay. It takes some time. So I'm gonna pause now right back. All right, we just downloaded kubectl. This is it. So let's make it executable. So this is number 2 is optional. So go to number 3, copy this, and let's make that executable. Let's make it, sorry, great. It's now executable. So let's set the environment variables. This is it. This is it. Form of 4. Perfect. Now let's push it to, though this is optional, but there's no harm. There's no harm. Let's do it. Fine. So if I should run kubectl, you can see it's coming. I say version, um, version hyphen hyphen short. Okay, version hyphen hyphen short. All right, this is the longer version. So hyphen hyphen short. I see client version is 1.21, blah 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 blah. The connection to the server, this is refused because we don't have our kubeconfig locally. So far we've been able to what install kubectl. All right, so let's hop back to doc our chat board. We have fulfilled number 4. We've installed AWS CLI. We've also installed IAM Authenticator, and we've also installed kubectl. All right, so let's go back to the top. We created an IAM user already. We have a VPC, so we are left with option number 3. So number 3 says create the cluster. So creating the cluster, we'll hop back to our console and I'll type EKS. I'm going to type it there, Elastic Kubernetes Service. Okay. Now, before we go ahead in creating Elastic Kubernetes Service, we need to create the role, cluster role, and yes, create cluster role and worker nodes role. All right. So let's create those rules. So for that, I'll go back to IAM. I'll go to IAM and I'm going to create the both roles. I'll create the first role for the cluster role. I'll go to roles, click on roles, click on create role. All right, it's for an AWS service. Um, okay, use. All right, one sec. Okay, I'm going to click on create role AWS service. Now come down here. Choose service, choose case, use case for other AWS service. So I'll come here and type EKS. So this is what I want. Then I will choose EKS cluster. Okay. Then I'll click on what next. All right. So this is the role I need. This is the role I need for the cluster. Okay. Cluster policy. All right. So this is the role. So just click on next, and give it a role name. I can call it EKS cluster row. That's fine. That's fine. That's fine. That's fine. Click on create row. Create row. It's being created. It takes some time. It takes some time. Okay, all right. We now have the cluster being created. Role, sorry, the role, EKS cluster role created. So so let's create one more role for the worker node. So create your role, new role. So that role is going to take the form of an EC2. So your worker nodes, they are actually EC2 instances. So click on EC2, then click on next, select EC2, next, then search for the roles we want. We just want three roles. CNI is one. Let's look for CNI. Okay. That will be Amazon EKS underscore CNI policy. Let's look for the order. The order would be node policy, enter. No, it's not there. CNI, node policy, node, sorry, node was, all right. This is another node policy. And the last one is container registry. Container registry, do we have it? Container registry read only. All right, container registry read only. So that's what we want. So three policies chosen. We click on next, selected, sorry. Click on next, and role name will be let's call it EKS worker role. EKS worker role, and these are the three policies. Click on create. So it takes some time. I'm gonna pause the video and we'll be right back. Oh, it's done. It's done already. Okay, so we've gotten two roles. We've gotten two roles. One is for the cluster and the other is for the worker nodes. All right, so now let's go back to our search bar and type EKS. So at this point now, we are going to create the cluster. We are going to create the cluster. So let's look at our dashboard. So this has been achieved. This has been achieved. Okay, let me say this has to be this. Now cluster, create cluster. Okay. So number three now, let's go back to there. So I just need to come to Amazon EKS. Now cluster, click on cluster, then click on what? Add cluster, or can click create cluster, whichever one. So the cluster name, I will say EKS cluster. Then the Kubernetes version, API version is 1.21. Mind you, our kubectl was 1.21 as well. So if I say kubectl version dash short, I have it at 1.21. So it has to correspond with the version of your API cluster. Okay, so this is it. All right. Now this is the role we created. Remember, EKS cluster role is for the cluster. Okay. Secrets encryption. We may need to allow AWS to manage that for us. All right. So click on next. And yeah, I have my VPC. So my VPC, I have two subnets. Okay. Okay, that's okay. Security group, I have Frank SG. I'm gonna take that. And yeah, cluster endpoints, I'm going to use both public and private. Cluster endpoint is accessible from outside of your VPC. Worker node traffic to the endpoint will stay within your VPC. That's okay. Public and private. Then okay, my CNI is giving me default. Okay, it's giving me that version. VPC CNI, that's all right. Uh, Core DNS is giving me that, and yeah, Proxy is giving me that as well. So let's see next. And next, okay, so this is all, and I'm going to click on finish. Great, great. All right. So while this is being created, I skip a point. A point is the Kubernetes architecture. All right. So Kubernetes architecture. So I'll just briefly explain the Kubernetes architecture. All right. So let's hop on to, let's say Google Kubernetes architecture. I didn't touch that. Images. Let me look for a simple image. All right, let me take this. Let me take this image. All right. Oh, sorry. Um, expand the screen. Okay. Okay. Now this is what's happening. All right. So Kubernetes Master. This is my control plane. So my control plane means is my cluster. So in my cluster, I have these components already installed for me. If I were to install Kubernetes from scratch using kubectl, I may have to install each of these components as they are. I will install etcd, I will install the kube API server, I will install the scheduler, I will install the controller. All right. This is, but since I'm using a managed service from AWS is managing all of these for me. They are doing all of these at the back end, at the background. All right. So the Kubernetes architecture is divided into two parts. We have the master and we have the workers. All right. Okay, let me start with the master. So the master we have, oh, sorry, apologies, please. So on the master, we have these components. You have the controller, you have the kube API, and you have the scheduler. So the kube API server, it acts as a gateway, all right, a gateway on the Kubernetes master. Okay, so it coordinates every other aspect or every other component of the Kubernetes cluster. All right. So the etcd is for storage, where all the configuration files is being stored. Then the controller is responsible for controlling other controllers. All right, so we have more controllers. Okay, let me do this elaborately. So on the Kmaster, going to take some time. On the Kmaster, we have the following components. One, we have the controller. We have the controller manager. So the controller manager is responsible for managing the controllers in the cluster. All right. So we have different controllers. Um, we have one of the controller. We have the node controller. Okay. Another, sorry. We have the replication controller. We have the deployment controller, right? Then the we have no controller is there, service controller, service controller. A lot of controllers are there. A lot. There are so many. Okay. So that is what the controller manager does. It has other controllers in it. Then we have the API server. As we said earlier, it is the gateway to the Kubernetes cluster. All right, gateway to the Kubernetes cluster. Okay, every component component is connected to the API server. Okay, API server. Then the third one is we have the etcd. Okay, etcd, it's a storage. It is the storage for the Kubernetes cluster, meaning that it stores all configuration files in the cluster. So all of your configuration file is stored in etcd. Okay. Then finally we have the scheduler, which is 4. Okay. We have the scheduler. All right. It is responsible for job scheduling. All right, scheduling. So that's what the scheduler does. This is on the master side. Okay, this is on the master side. Then let's have the one on the worker side. So on the worker side, k worker, k worker. All right. So on k worker, we have one. We have the kubelet. So kubelet is responsible for coordinating um where and what runs on a node. Okay, for coordinating where a pod or a container should run, and on which node. All right. All right, so kubelet is responsible for coordinating where and what runs on a node. Okay, and it's also it's also communicates. It also acts as a middleman between the K master and the K worker. Okay, K worker. So he is a coordinator. So kubelet is a coordinator. Kubelet is the coordinator between the master and the worker. All right. So there we now have another component on the worker, which is kube proxy. Kube proxy is responsible for networking. All right, networking in the cluster. All right, it creates the network and assign the appropriate network to the cluster. Then we have the third one, which is container runtime. So in here we use Docker. All right. So all of these we don't manage, we don't set it up. The AWS has set all of these up for us. All right. So we're just running the cluster and everything is being run. Okay. Container runtime. Okay. This enables, so here we've used Docker. We've used Docker. All right. This enables you to deploy containers and images to your cluster. All right. Now, then finally, we now have pods. Okay. A pod is the smallest unit in a what? In a cluster. Then finally, we now have container. All right. So container is an instance. Okay, this is an instance of an image. All right. So your container is an instance of an image. So if you can see, we've actually done justice to the architecture we've actually done good justice to the architecture. We've seen different aspects of the Kubernetes entire cluster. We have the master, K master, and the K worker. We've explained all of these components. We've also explained all of these components. Then there's one component missing, which is the kubectl. So kubectl is on the master side, kubectl. All right. So this utility is used to manage. It's a command utility. This is a command line utility used used to manage and the Kubernetes cluster. All right. So that's it. So that's all we have to say about the Kubernetes components. Okay. Kubernetes components. So that's it. So let's go back to our cluster. Let's hope everything is fine. It's being created. Let's refresh. It's now active. So our Kubernetes cluster is now active. So let's check for the cluster name. Let's click here, and EKS cluster is my cluster name. So that's it. So click on the cluster name. So far we don't have a worker node. So these are all the settings. These are all the settings. So now we want to add worker node. So I'll click on what compute and create a node group. So there are two ways. The node group is a server based is a server server based format, and the other one is Fargate, which is a serverless. All right, serverless. You won't see any server, but we are concerned with the server aspects. All right, so I'll click on add a node group. Add a node group. So the group name will be, let's say, EKS worker nodes. Let me give you that. Let me give you that. Then node role. Mind you, we created an EKS worker role. So this is the role we created. Then blah 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 label things. Next, click on next. And yeah, okay. The AMI type, which is the version type, we're going to use AMI Linux 2. All right, so that's okay. Capacity on demand. Okay, all right. The instance type, they're giving us T2 mic medium. Two, okay, by default, two CPUs. Oh, that's okay. All right, that's okay. Disk size is 20 GB. Okay. Maximum of two worker nodes. I just need two worker nodes. And right, node group update configuration, number one, blah blah blah. Next. Then the subnets, I'm taking the one I already have, which was the one I created. Okay, so if I want SSH access enabled, that's okay. Then I'll select my key pair, Dinero keys. I have this. If I want to access the worker nodes directly, okay, I have to enable SSH access for them. Then security group, I have my Frank SG security group. I'll click on next. Then that is all. That is all. Click on create. Create. All right. So while this is creating, it takes some time. Take some time. I'll pause and be right back. All right, now that our worker group is now active, it's active. So let's go to EC2 and see. So let's check the nodes. The nodes are ready. They are in ready states. They are in ready states. That's fine. Health issues, none to be recorded. EKS cluster is this, desired state is this. All right. So if I hop onto EC2 instance, I should see those two worker nodes being created. So EC2 instance should have, okay, so you can see them here, T2 micro and T3, sorry, T3 medium, T3 medium. So let me label it. Let me call it K worker. A worker one, and then this should be A worker two. Right. So now that we are all set, let's now hop back to our cluster, our command line, sorry. Now we are going to now connect, all right, connect our remote node to our Kubernetes cluster running on AWS. So the command is AWS, all right, EKS dash dash region. So my region is where's my cluster? EU West 2, I guess. EU West 2, then update update what kubectl config dash dash name what's the name of my cluster. It should be EKS cluster, EKS, it should be EKS cluster, EU West 2, all right, EU West 2, EKS cluster. What region is it running? EU West 2, um, cluster, cluster details. So EU West 2, EU West 2. So that should be, name is EKS cluster. All right. So if I should run this command and everything goes fine, we should get yes. Now, perfect. Now it has successfully added a new context. All right. Blah, 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 EU2, West cluster to my home directory. So I now have this file. All right. I've successfully downloaded my kubeconfig file from the cluster into my local machine. So this is what I would do. I will say cat.cube and I'll have it config. So let's clear the screen. So I have all of these. Okay, I just have only one cluster. So this here is my server. All right, this is my cluster and the name, context, blah, 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 blah. Okay, kind config, um, okay, at the top, API version, cluster, this is certificate. All right, that's great. So the next command I need to run as well is to export the environment variable. So I'll say export what? Cube config, config. So export that. Here is my home. Sorry, that's my home slash dot cube config. To what? Cube config. So exported. All right. So if I say echo dollar cube config, I should get that. That has been set. All right. Okay. So now if I say kubectl get service, let's see if everything goes okay. Whoa, whoa, whoa. Okay, 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 okay. All right. I have a reason why this is behaving like this. Kubectl get service, get service. Yes, this is expected. This is expected. You must be logged into the server, unauthorized user. All right. So I'm getting this error because if I do AWS STS get caller identity, if you can see what is coming up, lost signal. If you can see, Omero is not the user that has created this cluster. Now look at this. I'm logged into this machine as frank.legbose. All right, frank.legbose. And I have created, this user has created the cluster. and not Omero user. Okay, so what I will do now is I have to re-log in into my AWS tenants and issue this command. So I'll say AWS configure, enter, then the credential for Frank and not Omero. So I'm going to look for the credential for Frank. I have created that, the access key. This is the access key for Frank. Copy. Come here. Paste it. Paste. No, no, no. Copy. Paste. That's it. Then the secret key. Copy. Then paste. Region is same region, and that is that. So now, if I do AWS STS, all right, get caller ID, I should get that of Frank Legbose. And if I now run kubectl get service, all things being equal, we should have our update. So if I also do kubectl get nodes, everything should be up and running. So this is it. So these are the two worker nodes I have in my environment. And because of time, I think we have to end it there and continue with another series. So in the next series, we shall see how we can deploy microservices, all right, applications on our Kubernetes cluster. Thank you, everyone. Thank you for your time. Thank you, and have a beautiful day.